Hey everyone, welcome back. This is lesson 2 in Unit 5, and today we're going to talk about types of reactions. So in the last video, we talked about the conservation of mass and how to balance equations, and we're going to use it a little bit later on this unit, but today we're going to talk about synthesis, decomposition, single replacement, and double replacement reactions. So here is a picture. So right here you have a picture of 4 different reactions. So reaction 1, reaction 2, reaction 3, reaction 4. What I want you to do is look at the picture and look at the 4 possibilities they could be. Which of these 4 do you think is reaction 1? Which of these types of reaction is number 2? Which is 3? Which 2? I just want your prediction. So by now you should have typed in your response, and let's see how close you were. So first one we want to talk about is synthesis. So right here, reaction 1, this was your synthesis. Reaction 2 was your decomposition. Reaction 3 is single replacement. And reaction 4 is double replacement. So if you got that, well, then you got the lesson. If not, well, let's go into this a little bit more detail. So in a synthesis reaction, you have elements or less complex compounds come together to form a single, more complex thing. So in some examples, you have, 2 elements come together to make a compound. Small things, a bigger product. So what you should be looking for is multiple reactants. Most of the time it will be 2, and then 1 product. So multiple reactants, 1 product. And that's what you can see in all of this. So that's your synthesis reaction. Next would be decomposition. And so decomposition means you're breaking something down. So you have a complex compound being broken down into either less complex compounds or elements. So what you want to look for here is that 1 reactant and multiple products. So remember, everything is, before the arrow is your reactant, then you have your products. You're producing your products like that. So here we have 1 reactant being broken down into multiple things. So decomposition, breaking stuff up. Okay, moving along here. Next is single replacement. So this is where a single element replaces another element somewhere in a different compound. So what you want to look for is something by itself in the reactants, and then a different something else by itself in the products. So something is always single. So in this first example, we have aluminum all by itself, and then we have, at the end, copper all by itself. So what ended up happening, aluminum knocked copper out of that spot, so aluminum comes in, copper goes by itself. In the next example, lead is by itself, Fe is by itself. You always have something, an element by itself. Last example, O2 is by itself, and chlorine 2 is by itself. If it's one specific element by itself, that is a single replacement reaction. So something single in the beginning, something single at the end. Somebody is always, third wheeling here. Okay, last type is double replacement. And so here where, ions switch with other ions. And so what you would want to look for is 2 compounds in the reactants, 2 in the products. So 2 big compounds in either side. So here you have this plus this, which gives you this and that. So what happened is that your outside people, your PB and your I, outside people with outside people, and inside went with inside to form these 2 new compounds. So double replacement means 2 things are being replaced. Single replacement, 1 thing is being replaced. Double replacement, everybody gets a new partner. And so same thing for those other 2 compounds. Okay, so there are other types of reactions that we'll get to whenever we get to organic chemistry, but right now, these 4 is what you need to know. So let's just wrap it up with some quick questions. Which equation represents a single replacement reaction? And so, you guys should have said B. This is single. You have aluminum by itself, then you have hydrogen by itself. So this is your single replacement. A is your synthesis because you have something coming together. C is your decomp because you have something breaking apart. And then D is your double replacement because everything gets a new partner. Okay. Number 2, given this reaction, this is classified as A. You should say double replacement because you have these things get split in half and you have both things having new partners. You have two reactants, two products, everybody has a different partner. Lastly, what type of reaction is this? You should say single replacement. You have magnesium by itself, you have hydrogen by itself. Magnesium knocked out that hydrogen, switched it off, and that was it. So that's really all there is for types of reactions. Next time, we'll go over how to determine missing pieces in reactions. But for as of right now, that is it. Have a wonderful day. Bye.